for a job, find those people. Okay, presenting Kevin Bottomley. Give him a round of applause.
Hi. Okay. Can you hear me? Does that work? Okay. Closer. 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 Nope. Sorry. There we go. Good? Okay. Hi, I'm Kevin Bottomley. I'll be presenting about fighting Phishers' fake fronts today. We'll be looking at a couple different methods for doing this. So if we're ready, let's go. Some topics I'll be covering will be what phishing is, phishing techniques, commonly spoofed companies that you see, how these sites are made, fake website deployment, detection methods, and protections that you can employ to help prevent these attacks. A little bit about me. I studied computer networking and information security at San Francisco City College in San Francisco with an emphasis on network security. I'm currently a security analyst here at OpenDNS, where I monitor and track various traffic patterns and other malicious attacks that go on across the internet. I'm also an avid rock climber and the proud parent of a 10-year-old black Labrador. So what is phishing? It's a form of social engineering where people try and garner the trust of the sender, or the sender tries to garner the trust of the receiver of usually a malicious email. It's an attempt to gather usernames and passwords and other credentials to use to log into various websites, and also an attempt to get credit cards or money and other various items. It's also for gathering personal identifiable information such as your address, your birth date, social security number, anything else that they can use to emulate who you are. And a recent estimate by the RSA at the beginning of the year put the estimated loss in December of 2014 alone at $453 million, which is a quite substantial amount of money. So a couple of types of phishing that we see is spear phishing, which is where the attacker will learn as much information about the person or the company that they're aiming to phish and figure out who works there, what they do, and send a targeted email that usually spoofs that it came from inside of the company to add more realism to the look of the email. There's clone phishing, which is actually what we're going to be taking a more extensive look at here in a little bit. It's basically where the attacker will take a real website and clone it, and the emails that go along with it, send that to the receiver, and emulate basically a perfectly realistic looking website. And then whaling, where you have they target like CSO or CEOs and CFOs of companies because they usually have more access to the monetary aspects of the company, as well as usually insider information and other intelligence that the attacker would like to gather. You basically have two types of servers that are used in these attacks. The first is a dedicated server that's like this, where the domain name is actually meant to spoof something that looks like, so this is meant to look like, this is meant to look like the Apple website. You can see in the URL, or the domain is uk-appleidverify.co.uk. Clearly not an actual Apple website, but it looks very real. And then the other type of website is usually a compromised domain, where they will use various vulnerabilities in the website to place malicious pages at the end of the URL. Usually it's a little bit more hidden than this one. This is actually a website for some calligraphy ink place in the Philippines. Both of these domains are actually still active. By the way, I just pulled them out of phishtank.com yesterday. Apparently the site owner of this has not been notified yet. Recently there was the big Anthem breach. While this in itself, I'm not sure of the attack vector, but it led to a mass emailing of fake Anthem emails playing on the breach and basically using it as a scare tactic to get people to click on the link to either send them to a spoofed website or download malicious content. And then more recently, you had the breach at the State Department that led to a phishing attack on the White House, which divulged some, while not classified information, it was very sensitive in the fact that it contained the president's itinerary, which is somewhat public, but it had an exact time of every place that he would be, and foreign intelligence agencies tend to really enjoy this kind of information. So the anatomy of a fish, for you interested in biology. We can talk about that later. And then we have the anatomy of the fish that we're covering today. So it basically starts out where the sender will craft a malicious email to appear to be a valid email from a legitimate company, such as PayPal or Bank of America or any one of a number of legitimate corporations. The user clicks on the link and is directed to the phishing page, and then the user's asked for the credentials, such as usernames and passwords. Now, here's where it kind of splits off. Depending on the site design, the user can either be redirected through the use of usually PHP scripting, and then the credentials will be cached, and then they'll be logged into the legitimate site, or the user will be redirected to other pages that have been also crafted by the attackers to try and garner more information, such as the addresses and the birth dates, social security numbers, phone numbers, and all that, which we'll see an example of here in a little bit. And then sometimes you even see things where they ask for more information, such as a passport, driver's license, state IDs, or any copy of that. Then the criminals can use this for either their own personal gain, or more than likely you'll see it bundled as a package for sale somewhere on the Depot web for extremely cheap, like $5 gets you hundreds of people's information. And then you get redirected to a legitimate website again, that little example being PayPal down in the little picture. Does anyone here work for PayPal? Okay, because I'm going to be using you a lot, and I don't want you to block my stuff before I'm done. So how many people have gotten a phishing email here? Yeah. How many of you clicked on that link? Yeah. Wow, that's way more than I expected to answer that, actually. Of course, it's all for research. It's all for research. We'll get into that here in a minute, too. So some of the more commonly spoofed companies that you see are PayPal, Apple, Google, Gmail, Yahoo, Dropbox, and any number of financial institutions, Wells Fargo, Bank of America, HSBC. The list there can go on. So some of the commonly spoofed companies again, and so the numbers for these data I should clarify. So what I did was, if you go to phishtank.com, which is a community repository that people can upload phishes and verify them that they find, you can actually pull down the CSV of all of the verified phish that go on. So there was about 28,000 that were currently sitting there that were online and verified when I pulled the CSV. A big chunk of that has no attribution to it, so it means that it didn't have a company name that went along with it. So I kind of just stripped out that because it didn't add much value to it. So that left me with roughly about 9,000 domains with attribution. So I took the top 5, which is PayPal, AOL, this Post Italiane, which I believe is the Italian Postal Office, and then eBay and Google. So the 51% of PayPal is the 51% of the top 5 of those. And so the total of those 5 is 3,138, with PayPal accounting for roughly 1,600 of those. So just to give you an idea of where I got the number from. But either way, yes. Amazingly enough, at least on the Phishtank aspect of it, there weren't a lot of online verified phishes. Now, that's not to say, that there's not some that have been taken down. But that's just what the current online was from 4 or 5 days ago, I believe. But they are in the list, but the numbers are very small. So how are these pages developed? The costs are relatively low. A server costs you about $5, and then to buy a name, if you choose to set up your own, costs you roughly another $10. So it's about $15. Usually it's not actually the Phishers' money because he's already phished someone previously to you. So he's actually using your money to pay for his new stuff. And then a couple other the commonly used tools are the social engineering toolkit, which the name is kind of self-explanatory. It's a toolkit for social engineering. It has a whole swath of stuff in it, from targeted phishing attacks to mass mailers. The list goes on. I've left the sorry. I put the link up there. It'll be in the slide deck that I put out later. And then, how many of you have seen HT-Track in action? A few of you? Yeah, it's a pretty amazing tool. It's meant for offline web browsing, as they like to say, but it actually will copy a web page completely. It'll mirror all of the links and all the URLs and all of the CSS and everything else that goes along with it, which we're going to see here shortly in action. So what's the deployment? Well, it's easy enough that I can do it, which means that pretty much anyone can. It's just a few clicks, well, not clicks of a button. There's a Windows version for HT-Track, but who uses Windows? How long does it take? Well, we're going to see here in a minute. It doesn't take very long at all to deploy. So our detection methods. For those of us that remember this game. So basically we employ three main detection methods here, or employ three aspects of the detection method. The first is the ASN of the company. The second is the IP address or the net block that the companies use. And the third is using what's called natural language processing. The ASN is basically part of the autonomous system. So it's a collection of all the routing prefixes for all of the IPs that basically tells your computer how to get from point A to point B on the internet. And as you can see, if you go to the bgp.he.net website, if you just put in PayPal or any company, it'll give you a list back of basically every ASN and every net block that deals with that company. So it's a really good source of information for building up the data set that we're going to look at kind of here in a little bit. Internet protocol address kind of speaks for itself. It's basically a phone number for the name on the internet. So basically you don't have to remember that 67.215.92.211 is OpenDNS. So the question is, do we track the ASN of the Phake website? Sorry. We'll get to that actually shortly. But so basically what you do is you backtrace from the initial domain and then grab its IP, and then you basically go and get the ASN from the IP. So you backtrace all the way back from there, which, yeah, is that? We'll see here in a second. I should have that slide in here. And then you have the main aspect of the model is actually using natural language processing. So basically what natural language processing does is it extracts patterns from text data using stimming, and we'll employ the natural language toolkit, which is a Python library, and also something called edit distance. So stimming is basically when you take a word and you break it down into its root form. So in this example, you see update, updater, updates, updated, and updating. When you stim it down to its root form, it becomes updat. So you can use this to kind of start breaking up your strings into like one common word. And then using the natural language toolkit, you can kind of see this, you know, in the example. You import the library, you create the stimmer, you put the words in the list, and then when you iterate over the list, you end up with updat, 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 updat for each one of those 5 words in the words list: update, updates, updater, updated, and updating. So you can easily figure out what the stem part of the string that you're looking for is for your data set here that we're using a little bit. Second thing that we're going to employ, I guess it's actually the third, is edit distance. So it's how similar to strings. And you can think of it the same way that like spell check and autocorrect work. When you start to type in a word and you mistype one of the letters, it'll be all like, do you want to make it this word instead? Because it assigns it a penalty score, which is basically the minimum number of editing operations it takes to change the string that you typed into the string that it believes that you want to actually type. And so there's actually 2 kind of numerical penalties that you can assign. The one that we usually employ is this one, where you have insertion, deletion, and substitution, with each one having a rank of 1 point. And then there's a Levenstein model, which assigns substitution the number of 2 instead of 1, but we use a really low threshold, so it doesn't. We're not going to cover the Levenstein model right now. So an example of the penalty assignment, right? It's assigned based on the number of operations needed to change one string to the other. So we'll take OpenDNS as an example for this. So when you try and change OpenDNS to OpenDMS, as you can see, nothing happens for the O, the P, the E, the N, and the D, but when you get to the N, it's actually being substituted for M, and then the S is the same. So by substituting the N for the M, you assign it a penalty score of 1, because it took one operation for the string to change. Going a little bit deeper, oops, a little ahead of myself. When trying to turn intention into execution, you basically delete the I, you substitute the N for the E, you substitute the T for the X, the E doesn't change, you insert the C, where the asterisk is up there, and then you substitute the N for the U, T-I-O-N, they're all the same, no change. You have a penalty of 5, so the penalty is greater. So, as I said before, we'll have a little demonstration here about what it takes to actually deploy one of these fishes just to kind of set. I kind of just made a video because it was a little bit easier. So what I've done here is I've created kind of a fake spoof PayPal website, email address, who's going to act as my victim. And then this is my malicious web server that I've created. So you just type in httrack, you give it a project name, call it PayPal, path it wants to store it, so basically what file directory you want it stored in, the URL that you're giving it that you want it to mirror. So we want to mirror basically the entire PayPal website. And you don't have to go all that deep into it, but I'm going to anyway. So you click number 4. So basically to traverse the entire PayPal website from A to Z. You can use a proxy. I didn't use a proxy. That's why I have a VPS. You can wildcard it here, so it looks for only certain things. It skips other things, so it can just go and take everything that starts with www, or skip anything that starts with .zip. You can give it some options. The list is long. You can always RTFM if you really want to figure out everything it does. For those of you that don't know what RTFM means, I'll let you Google it. Oh, I'm sorry. Yes. Yeah, hold on. There is a way to... Oh, sorry. Yeah, he asked if I could. Sorry. Do you want the font increased, or you want the picture itself? Yes. See if this might be a little much. Oh. One more. All right. Better? Sorry, it was a lot darker in my basement when I was doing this. So, continuing on. So, basically what happened back there was I started the crawler to go and crawl everything. And now I've switched over to the social engineering toolkit to craft the fish in itself. So you give it a send to email. So we're going to send it to my fake PayPal victim here, if I can type correctly. Basically what's going to happen is it's going to ask for a few options of how you want to craft your email. Because you can send it out in a mass mailer, you can send it out with a few different options. And since I didn't want to spam everyone in the world, I just selected one. Oh. And then I also have a fake PayPal sender email too that I was using for the demo. So you can actually run a mail server too. So if you have your own mail server going on your server, you can actually spoof it even more than just coming up with this horribly crafted PayPal Gmail account. Here we're going to make it seem like it's verify@paypal.com from the sender, even though it's not really from verify@paypal.com. You have to pass it your password. Of course, you want it to be high priority because it's very important the sender or the receiver gets it. Give it your subject line, something going along the lines, account information's been changed, your account's been compromised, something like that. And then, of course, no phishing email is correct if it doesn't have some type of grammatical error in it. So we put information. We're going to send it as HTML instead of plain text because the email is crafted with HTML. I have this already pre-made, handy HTML email that I've made, which will spoof the actual real email address or the real domain site in the email, as we'll see here shortly. And that's just a little href on document stuff. Pretty simple, straightforward. Paste it, hit return again, leave it a blank line. Now, somewhere here. Oh. Yeah, so as you can see, like it says phakepaypalupdate.com. That's the website that I bought to use for my spoof. But then if you look down, it's kind of tough. It's kind of tough to see. But I'm basically spoofing that it's from verification-paypal.com, just to add a little bit more legitimacy to the email. Send it, and off it goes. Now, yeah, we're done there. So the other thing that you have to do in the meantime, which I probably should have done the other way first, but it takes a while for httrack to go and get all the stuff that you want. So now you have to go to the directory where you stored the files that have been downloaded from httrack, and then start copying them over to where the landing page will be for the link in the email. Takes a second. So usually what the attacker will also do is they'll have a crafted PHP page already ready to go, so that they'll take the main landing pages, and then they can have kind of a man-in-the-middle aspect, so that when you get to the page that you're about to see here in a minute, when you click the log into the page, it'll basically man-in-the-middle your credentials, and it'll either send you to more web pages that they've crafted for more information, or just ship you off to the legitimate site. And somewhere, there it is. Verify@paypal.com. And it's kind of, yeah, you can see it. So as you can see, the link actually says verification-paypal.com, even though that's not where we actually end up, because we end up at fake PayPal or paypalupdate.com home.html. But it only took about 6 minutes from inception to deployment. And then, of course, there's a couple other steps that go on with it, like I was talking about, like the PHP pages that would be, basically you would just change the way that the document sends you from the actual PayPal source code, and then you would change it to your own pages that are also stored in the same directory down the line. I believe that is the end of that video. So it's really simple to make one of these web pages. Yeah. Oh, sorry. Uh-oh. There we go. So usually what we've seen in the past is, and this is not actually a copy of the page that I deployed. It's one that we found using some of our detection methods. So as you can see in the top left corner, it's securitypaypalcenter.com hyphenated. And this is one of the pages that I found when I was going through some pages a while ago. So basically, after you entered your credentials, it was taking you here. So it's asking for your address, the city you live in, all that stuff, your phone number, and your social security number nonetheless. So here's where they start trying to harvest your credentials in the first part. And then after you click next, I'm not sure why. Sorry, what's going on here? Sorry, technical difficulty here. What is going on? Sorry, my slide doesn't seem to be forwarding for some reason. Come on. Really? What's going on here? Are we fixed? What is going on? Maybe. Sorry. As always happens. Oh. Huh? Yeah, it's my next option here. Sorry, my new laptop seems to be here. Would it start over? Oh, let's see. Fail. All right, I think we're fixed now. Okay, sorry about that. Technical difficulty. So, Social Security number gathered. The next page that we went to was credit card information. So it asked for your cardholder name, the card number, expiration date, the card security code, and then the thing that stuck out the most was asking for the PIN number as well, which most websites won't ask you for the PIN number, as that's the point of asking for the CVV on the back of the card. And this particular website actually validated your credit card to make sure you weren't just putting in some type of BS card. So it was using the Loon algorithm to make sure that it was actually valid so that you weren't tricking the trickers. And then the last page of this actual website asked you to verify your information even more. So they were like, send us your passport, your driver's license, your image of your credit card, and proof of address. And then you could nicely submit it to them all in one fell swoop. So that was pretty nice of them, just to make sure that you were verifying who you were as they were stealing your information. So some of the things that kind of stuck out from the email I sent that you can look for in your emails would be this. So even though it says verify at paypal.com here, you can see in the actual sender part of the email where it says fake PayPal sender at gmail.com. That sticks out. The fact of the fake web page that doesn't have any HTTPS involved here, so none of the information that you would pass to it would be encrypted. And PayPal will obviously have their SSL cert and will have encryption going on. So what else? Actually, here So this model can also find things that have to do with like the dark hotel domains. So Microsoft XPUpdate.com, JavaUpdate.flash.net, AdobeArm.com, MicrosoftUpdate.info or info.com, FirefoxUpdata.com, and GmailBoxes.com. I actually have, so you might be wondering like what you can do to kind of help catch this stuff in yourself with the model. So kind of what we do here at OpenDNS is we have the same a model deployed because we see so much traffic at like 50 billion requests a day or somewhere in there. So we're able to actually sit there and watch for these kind of one-off domains. So what I did in the process, and hopefully I don't break my machine again, was I've also deployed my own DNS server that I basically pointed a bunch of traffic to. And one of the things that was pointed, so when that link was clicked, it actually resolved around the DNS server that I had deployed. So using the model that we use at OpenDNS, looking for the editing distance and the stimming, you can actually go through. So I have this log file somewhere. So this is basically everything that my DNS server has been catching since I pointed stuff to it a couple days ago. I think there's somewhere around the realm of like 5,000 queries in it. So using the handy dandy, there. So if we run the script, what this is going to do is basically go through my entire query log and find out of all that, if I get into the right thing. So what it's doing right now is basically going through the entire query log, and it's basically taking all of the domains in the query log, converting them to IP address, testing the IP address against the ASN, and then it's going to, if the ASN is in what's a whitelist that we've created in our data set, it's going to, if the ASN is in the whitelist, it's basically going to take that domain and just keep passing it through, because it's obviously not malicious because we've already whitelisted it. So as you can see, we start seeing that. Kind of hard to see. Oh. Sorry? White on black, or black on white. It doesn't matter. I'll take anyone's suggestion. Let's see. So you can tell that I've actually, well, you can kind of tell that I actually ran this quite a few times. So out of like the 5,000 domains that are in the query log, it's basically just parsing out, why is this white on? Thanks. Sometimes I play with computers. So I actually, while I was making all this happen, that's why you see so many of them, but it's only catching the ones that so this one, it's basically flagging on the updat part that I was showing you earlier from the stimming, and then comparing that to the brand name, and then taking the ASN and seeing that the ASN is bad, and then being all like, this is a high priority, someone clicked on this domain, you should probably go investigate because someone just got phished. So the question was, I'm checking to make sure that this domain doesn't match the same ASN as PayPal's ASN. Yes, that's exactly what is going on. It's basically, it's going and it's figuring out the exact IP address for where this domain sits, and then it's taking that and running it against what the Pi ASN library, and then it's converting that off of the BGP tables to figure out the actual ASN, and then it's taking that and then testing that ASN against a known bucket list that we have set up of so basically you go through and you make a table of each, so Google has its set of ASNs, Google has its set of ASNs, and on down the list. And so once you compile all of those ASNs, then you can just bucket them. And then if it's in that list, it can just automatically push it through, and you're not using the resources it takes to, to even check it, because you've already, the odds of a fake PayPal domain being on PayPal's ASN are pretty much next to none. So we don't even need to query that. So if the ASN is in the whitelist, then we just keep going to the next one. So since this one, since it was, the stimming happened, the editing distance happened, so it was penalized, the ASN was wrong, that's how it gets flagged. So that's how people in a network can actually make it a little bit, since we have so much data, like it's easy for us to see this, but like usually smaller companies don't see the amount of data we have. But it's really easy to go and deploy, like I think I built this DNS server for $5. So depending on how much you need it to scale, you can give it more RAM, more hard drive space, and all of that. But definitely make sure that if you're going to build one for your own company, you set up the access control list, because next thing you know, you'll be participating in a DNS amplification attack if you don't. Just a word to the wise. So let's see if I can not kill PowerPoint again. Come on. It doesn't work very efficiently, does it? I'm just going to kill this. Microsoft. Sweet. Okay. So that's basically the same model that I used to find the fake PayPal domain and the query logs there. It's the exact same thing that we use to find other threat attacks. So, like I was saying earlier, the dark hotel domains, APT1 domains, this works all across the board and not just for phishing. So you can use it to get a lot of insight into pretty much any attack or any malicious URL that's on your network. So, back to the phishing, some of the takedown processes that it takes to take one of these fake phishes down is you would notify your, like the ISP of where the domain is sitting, the registrar of who the domain was registered through. You can contact the site owner, but if it's a dedicated server, they're probably going to ignore you. And then you can also contact Microsoft, Google, and Mozilla, because they'll put it into their browsers, so when you go and visit, it sends you that big red, this is a phishing page, warning. So some things you can do to help kind of protect yourself even more. You can enable two-factor authentication on every single thing that allows it. Check for HTTPS in the URL bar. Use password keepers like LastPass and KeePass. This allows you to use different passwords across every different site you go to, so even if one of your sites is compromised, the odds of them compromising another one are next to null. And then by comparing the ASNs, the IPs, the WHOIS, and the natural language processing for the site validation. And lastly, don't click on random crap, because that's the first vector. Questions? I know. Yes. Go ahead. So the question was, do we ever see phishing sites with valid HTTPS? And while I have not actually seen one, I was actually going to make mine one because it's not really that hard. But I think it's more of like a couple extra steps that the attacker, like that would probably be something for like a really deep down targeted attack against someone. Just because like like they don't want to spend the extra money usually, and if they can just mass email it out to people, like, you send it out to enough people, you're gonna get a few clicks. But it's a good question, because I actually thought about doing it, so just to disprove myself on the HTTPS thing. So that's part of building building up the training set for the model. Is like sometimes you will get like a random like FP in there. It's bound to happen, and then so you have to go and investigate it a little bit more. That's where a little human interaction comes in. But it does happen, and then you just add it to the whitelist and figure out if it's actually like a legitimate PayPal domain before you do that. Anything else? No? Yes? I'll put the slide deck out there somewhere. So there's my little Twitter handle. That's a 3 and a 0, eliteness. Actually, every rendition of my name I tried to get was somehow amazingly taken, which I don't really know how. But yeah, if you go and like look at this, I'll probably put it out sometime today. Is that it? Sweet. Just want to say special thanks to Jeremiah O'Connor over there. He actually helped like with a lot of the code base that I was using. So really awesome stuff. And if you happen to go to Source Boston, he'll actually be talking about the natural language processing and stuff even more. And maybe if he's really lucky at RSA this week. And then of course the OpenDNS research team and BSides SF itself. And for those that haven't eaten lunch yet,